Okay, let's continue. So our task now is we want to visualize the decision tree, and probably that's very important because when you decision tree is one of the a few models, and you can really present in PowerPoint if you want to, and you can show people the structure of the decision tree. So if you want to create one, there are well, the way that I have figured out is, well, you have to install a package called Pi.plus. So originally there is another version called Pi.dot, but now that person has that package has been replaced by the Pi.plus. So number one, you want to install the Pi.plus to Anaconda. Well, of course, you can't do this on the Dive 8 server. You have to do this on your local machine. Okay, this is the first step. And after that, you have to install a standalone tool called GraphViz. So you have to install that, and after that, you have to set the environment variable. So you have to add the path of the graph viz to the environment variable. So after those steps, and then you should be able to get this visualization of the tree structure. So well, you don't have to do that, or there might be other ways available which are easier. But this is the way that I have figured out to visualize a decision tree. So we are still doing the kyphosis dataset, and as you remember, we are more absent than present, right? So if we start from this root, and then the absent should be 45, and then present should be 11. So, and the first, based on the decision tree we have got, the first decision will be whether the start is smaller or equal to 8.5. So if it is true, and then we will go to the left side, otherwise we will go to the right side. And then for each node, we are only making a binary decision in this case. So this is how the decision tree in scikit-learn is built. Remember at the very beginning of this lecture, we had this tree. So for this tree, we can split the current node into three directions. However, in the scikit-learn, we don't do that. So for the decision tree in the scikit-learn, we always do binary decisions. So if we go down and down and down, and here, so we have a leaf. So on this leaf, we have a total of 12 samples, and the Gini is a 0. So what is a Gini? I'm gonna cover the Gini later, later in the next lecture. Okay. So and then for the video, for the values, we have 12 present. Oh, sorry, we have 12 absent and 0 present. So we can say this is a pure node, and this can be made as a leaf, right? So if we go down and down and down, and you may have this observation. Remember, in our dataset, if we don't count the kyphosis, we only have 3 features, right? So just for 3 features, and look at the tree we got. So this tree is actually huge. It is very deep. So you may feel, is that really necessary or not? And personally, I would say having such a big tree may not be that necessary. And this will bring us to a topic: why decision tree needs to be controlled while we develop or while we grow this decision tree. And this will be the topic later, not the topic for today. Okay? So the next point is, if we want to make a decision, so if we have a sample age at 18 and the number is 10 and the start at 10, and how do we make this prediction? So to make this prediction, and we do have to start from the beginning. So start smaller or equal to 8.5. So our start is 10. So it will be a false. So we will go to the right side. And then we visit this node. And if start is smaller or equal to 13.5, it is true. So we go here again. So this is how we make the prediction. So once we build the tree, we are gonna use the tree to make the prediction, not the training samples. Let me say that again. Once we have built the tree, we are gonna use the tree to make the predictions. We can leave the training samples all alone. So why it is important? Remember, when we talk about the time complexity of the k nearest neighbor, there's one problem. The problem is, well, if the training set is large, and to predict one sample, we have to compare the distance between that one sample to all the samples in the training set, right? So for the KNN, the story is different. For the KNN, we are making use of all the training samples to predict one sample in the testing set. Okay, so that's the reason we are saying for the KNN, well, the prediction time is very long. The prediction is slow. However, for the for the decision tree, the prediction is much faster. Okay, so we are going to start from another data set. So that is, we are trying to predict whether an employee is going to leave the company or not. So this is the column we are going to predict whether this person is going to leave or not. And then we have a bunch of the features, and we have most of them are numerical features. However, we do have two categorical features in this case. So we keep the y as the df with the column left, and for all the remaining features, they are the features. They are the training features. So we do the train and test split, and then we want to make the decision tree, and then we want to do the prediction. And this is what we found. Well, it says again, could not convert string to float low. Well, we have seen this before. And when you see that, this means we have a categorical feature, and the scikit-learn doesn't like that. So we have to figure out a way to fix this this column, and this should be the department of the department of the employee, and also the salary. Okay, so in the next video we are going to work on the solutions to fix those two categorical features before we can move on. So let me pause here, and I'm going to see you in the next video.